Hello guys. Today's problem is 417 Pacific Atlantic water flow. So, what's the problem is like we have given a M cross and rectangular Iceland. Okay, the borders both on the Pacific Ocean and the Atlantic Ocean. The Pacific Ocean touches the Iceland's left and top edges. Okay, and this is one is left and this one is top. Okay, and the Atlantic Ocean, the remaining one, the right one and the down one. Okay, the Iceland partitioned into grid of a square cell. Okay, you can see you are given an m cross n integer matrix where heights of r comma c represents the above sea level. Okay, means how much above they are from the sea level. The Iceland receives a lot of rain. Okay, and the rainwater can flow neighboring cells directly north, south, east, west if the neighboring cell's height is less than or equal to the current cell height. Okay, so basically, he's trying to say like the water can flow from a cell if the neighboring cell have less height from the current cell. Okay, like from this cell 3, water can flow through 2 and this 2, not the 4, not the 5 because they have greater height. So that's the question. So what we have to find out? We have to find out a 2D list of grid coordinates where we have to give the coordinates of each cell in which water can flow from cell to both the Pacific and Atlantic Ocean. Okay. So the problem is about finding out the cell coordinates from which the water can flow in the Pacific Ocean and as well as into Atlantic Ocean. Okay. So in simpler word, we can say find the cell coordinates from which the water can go to the Pacific as well as the Atlantic. Let me show you the example. Right, suppose this is the matrix we have, and so say like first observe this coordinate and this coordinate. Okay, these coordinates will be always be the answer. The top rightmost and the bottom leftmost. Okay, so these coordinate will be always will be the answer. Always will be in the answer, not the answer itself. Okay, why? Because you can see like if water is from this cell, then water can go to this direction as well as in this direction. This direction is Pacific, you can see P, and this direction is Atlantic. Okay. So now I am going to say up reframe the problem. Like what problem want to say. Okay. You can see like suppose you like this type of problem and they are screaming about BFS and DFS because you have to check neighboring cells, okay? And you are only allowed to move in four direction. Like yeah, okay. North, east, west, and south. Okay. These four direction you are allowed to move. Okay. So what we have to do? I'm going to reframe the problem. I'm going to reframe the problem. So okay. So let's carefully listen that. Okay. So now what we have to do? We can't apply simple BFS or DFS to move the problem. Like we want to reach to both ocean. Like if simply we want to reach Pacific Ocean or Atlantic Ocean, then we can simply use DFS like what we use simple like we insert into the queue and pop out from one by one, and similarly we do that. Okay. So now the problem is like how we find. So the idea is like there is a Pacific Ocean. Okay, let me change my color. Okay, so it is Pacific Ocean. Okay, this is Pacific Ocean. Okay. And this one is the Atlantic Ocean. Okay. So what we have to do now? We need to find like listen carefully. Now I want to find the cell at which we can reach from Pacific Ocean as well as from Atlantic Ocean. Okay, what I said? I said the cell at which we can reach from Pacific Ocean as well as Atlantic Ocean. Like suppose, like yeah, okay. So suppose this one, okay, which in my color black, okay. Suppose this one, okay. So I have to check is this still reachable from Pacific Ocean, and again is this still reachable from the Atlantic Ocean. Okay. So you I draw this line for a reason. Like how you will check if a cell is reachable from Pacific Ocean. So you have to check like you have to check for this and for this. These are the Pacific Ocean boundary. If in if in the boundary, which are the cell, like I'm going to rephrase my sentence, like from each of the boundary cell of Pacific Ocean, in whatever cell, like whichever cell you can reach from to 4. Okay, then it like you can simply I want to simple say like if you can reach from here, 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 and reach from here, as well as from here, from here. So these are the boundaries you can enter into the Pacific Ocean. Okay, so like I have to check is this four reachable from these boundaries, any of these boundaries. Like okay, so I can say like yes, like 4 can go to the 3 and 3 into the Pacific Ocean. Okay, then Pacific Ocean true. Okay, it is give true. Okay, and for the Atlantic Ocean, like 4 to 4 because it is allowed. There is a sentence. Okay, there is written a sentence equal to. Yeah, less than or equal to. Okay, then 4 to 4 and 4 to Atlantic Ocean. So now the problem become like we have to find the cells which are reachable from Pacific Ocean and the cells which are reachable from the Atlantic Ocean, and we then take intersection of those. Okay, like suppose I said like I'm not going to write the coordinate. I simple write suppose cell number 1, 2, 3, 4. These cells are reachable from Pacific Ocean. Okay, cell number nebula 5, 4, 2, 3, and 6. These cells are reachable from these from Pacific, these from Atlantic. Okay, so now what we have to do? We have to take the cell from which we can go to both Pacific as well as the Atlantic. Okay, so like 1, 5, no, 1, 2, no, yeah, here is 2, here is also 2. Then I will put the 2 in answer. Here is 3, here is also 3. And I will put the answer into 3. Okay, then this will be our answer. The intersection of Pacific and Atlantic Ocean. Okay, I hope you got the idea. Okay, so now move to the code. Yeah. I simply write a BFS function because we have to find for Pacific as well as Atlantic. The BFS solution is taking the argument like nums array. Nums is basically your height array. Okay. And the Q, Q is basically what? Q is basically for Pacific. You have to put all the border element, okay, into the queue. Like these element, okay. These element will be go into the queue which you made for Pacific Ocean, okay. And the other one is like which you made for other means Atlantic Ocean, okay. These boundary will be covered by, sorry, I mean that these, okay. These, okay. So these you will need it for the Atlantic Ocean. Sorry for the bad drawing. I'm not very good at drawing. So basically Q and the vector visited for each one. Okay. So like let me go through line by line. Okay. So what I do, simply size. Okay. So I made two queues for Pacific and for Atlantic, Q1 and Q2. And similarly two visited vector for Pacific and Atlantic. So like I told you Pacific top plus left. So what we are doing? We are pushing the elements, these elements, okay, these elements in Q1. Okay, Q1 dot push 0 comma I. Okay, 0 is ensuring the zeroth row and I is changing for column. Okay, so as well as I am marking them visited. Okay, similarly for left column means first column. This is first row and first column. Okay, so same for the Atlantic Ocean, the bottom and the right. Okay, so simply I call the BFS. So what the BFS is doing? BFS is simply taking the direction and checking the queue is empty or not, popping out the first element, okay, and traversing it neighbors basically, okay, and applying a condition where this should be true, like nums of neighbor, like height of neighbor should be greater than from the current one, okay, so that water can flow, okay. So I'm marking them visited and pushing into the queue, okay. So after finishing, we are simply now for the answer we are taking the intersection. What we have to do? Like we have marked in the visited area, like what we visited, okay, which are similarly visited. So in visited array, we have to visited array. So in both visited array, which cells are the intersection, like in both which cell are visited, we are pushing them into our result basically. Okay, so you can see simply, and I am returning the result. You can show you my submission. Okay, this is my solution. Okay. So that's about all this problem. Is basically applying BFS two times. Okay. Thank you everyone.